Can everyone hear me okay?
Yes.
All right, excellent. So just a quick survey here. How many of you are coming at this from a developer perspective? Okay. How many of you are security professionals but not specifically developers? All right, pretty much everyone else. Is anyone here as completely non-technical person, maybe you run a business, you're concerned about your applications, anything along those lines? All right, so entirely tech people. Okay, so a little bit about me. I've been doing e-commerce for a while, before there was PCI. Programming before the web. And I don't feel like I'm that old, but I feel like I'm getting to the point where I could be a historian on the World Wide Web. Things are progressing so quickly. And then finally, if there were business people in the room, and even for tech people, I think it's important to understand that there's a difference between technical objectives in an application, technical objectives that you're trying to achieve, and then business objectives and business priorities. So a lot of times technical people will look at a problem as a challenge and how they can efficiently solve that specific problem, and they're not as focused on the business objectives. And so it's important to understand that as well. So with all of you being technically oriented, you probably already know what a WAF is, a web application firewall. Similar to the same kind of thing you would install on your home PC, just basic protection. And so I'm going to run through really quickly some of the features of a WAF, web application firewall, in the traditional sense, just to give you so that we're all on the same foundation here with what I'm going to be talking about in terms of introducing a framework for a PHP-based WAF. And this is going to be applicable to other programming languages as well, but I'm coming at this from a PHP perspective, so I'll present it from that viewpoint. So if you're running a SaaS company, it's useful to have some protection in place. Obviously, a web application firewall is a way of addressing some of the security concerns of your application. If you have an e-commerce website, it's obviously useful to have some security measures in place. And finally, if you just have a website, the reality is today that even if you're not doing e-commerce transactions, that website still, even if you're not making a lot of revenue specifically off the website, if that website's hacked, that may be a huge liability for you, for your reputation, for your business's reputation. So, as developers, you all write secure applications, right? They're impenetrable. Why would you need any additional protection on top of the security that's already built into your application? And the reality is, no matter how good a programmer you are, and if you've been following PHP for a while, if you've been following pretty much any language for a while, obviously there are always vulnerabilities associated with anything. And so in PHP, you can do the most secure coding, you can follow the best practices, and still get bit by some underlying vulnerability in the PHP language itself. So even if you think you're secure, the reality is that you really aren't secure. And if you think that you're secure, you really don't understand the attacks that are constantly, every single day, every hour of every single day, being directed at your application, at your website, at your e-commerce website. So WAFs in the traditional sense have been available for a while. They've been available in physical forms that you put in your data center. They're now available as software-based cloud solutions. Everything's available now in the cloud. And it seems like a lot of these WAF solutions are becoming more cloud-oriented. It's faster to spin these up. Companies can sell them cheaper. There's some other advantages as well that I'll cover here in a minute. Costs for some of these, generally hardware solutions run more than your cloud-based solutions. Typically, you're paying for the hardware as well as whatever the software application is that's running the WAF. Cloud solutions generally are running thousands of dollars a year. And probably you've heard of these names before: Hardware Solutions, Fortinet, Imperva, lots of others, Virtual, and there are lots of these guys actually now coming online: Cloudflare, Encapsula, and of course lots of others. And just a side note here, Imperva actually has purchased Encapsula, so kind of they're in both arenas now. Some of the features of a web application firewall, the reason why you might install it, in particular if you've been running legacy applications that you don't have the source code for, proprietary commercial applications, what a WAF allows you to do is something called virtual patching. So if you know some specific vulnerabilities of that application, maybe it's no longer maintained. Maybe the company that wrote that software is out of business, and you can't do anything, but it's still a critical piece of architecture for your company. What a web application firewall will let you do is something called a virtual patch. And this is where you know what the vulnerability is. Let's say it's a particular string that's sent to the application that causes a buffer overflow. Your web application firewall can intercept that and basically drop those particular attacks from your application ever seeing that come through. So that's an advantage that a traditional WAF offers you. Reporting for compliance purposes is probably, again, one of those things that, from a business perspective, you may not feel that you need the security of a web application firewall, but once you hear that it will help you with your reporting responsibilities, suddenly it looks like a great solution. So WAF does give you some of that reporting capability as well for compliance. Data loss protection, again, now there are all kinds of security features that you can tack on to whatever appliance it is that you're putting in your data center or your cloud solution. And so data loss prevention is one of those as well. It can filter out and see what packets are actually flowing out from your server. Denial of service attack mitigation. And this is a case where if it's a cloud solution, all of that traffic is being intercepted before it ever reaches your data center. So this is kind of an area where a cloud solution can be a better solution than your physical hardware solution. Because if you've got a physical hardware solution, even if it has some denial of service capabilities, still all that traffic is coming into your data center before you ever touch it. Cloudflare is a pretty good example of a popular example of a cloud solution used to mitigate denial of service attacks. And then finally, again, these features that providers can now tack on. One of these is content distribution networks. So these cloud providers, in addition to offering you the denial of service attack protection, because they've had these data centers all over the world, they can now provide you some content distribution network capabilities as well. Really what I wanted to talk about here is what you can do with your own application inside your own, with your team, inside your company, or maybe even outsource this particular component of your application. The nice thing about what I'm presenting here is that your existing core team who's focused on building application features doesn't have to be the same team that's focused on the security component of your application. And so if you're trying to kind of create your own security solution here, there are obviously do-it-yourself solutions. Mod security is a big one. And so if you come from a traditional background in managing servers, if you've worked with a hosting company before, probably mod security is not anything scary, and you know exactly how to use it. One of the issues with mod security is that, number one, it's really easy to break an application because you're too strict in terms of the rules that you apply to your application. It's also, if you aren't strict enough, you can end up really, filtering out some of the most obvious attacks. But again, you're not building in the functionality that's specific to your particular application and addressing potential vulnerabilities specific to your application. OWASP actually provides a core rule set that can be useful. And again, even if you decide to go on and do something else, it's still useful to use mod security with this basic core rule set that OWASP provides. The advantage there being you don't have to really know a whole lot about mod security to take advantage of some of the benefits that it offers. Config server security and firewall. This is, again, is a firewall that runs on your server, the same analogous to software firewall that run on your computer. And the reality is that all of these do-it-yourself solutions are valuable, but they really don't get you to the point that you need to be today. Today, attacks are extremely sophisticated, extremely targeted, and if you have an open source application, your attackers may actually know more about your application's vulnerabilities than you do. The reality is a lot of companies are investing most of their efforts into building great new features for their application and not so focused on how to break their own application. Attackers have a different priority. If you have a website, like 25% of the rest of the internet does, running WordPress, you're a big juicy target. WordPress historically has had security issues. And even if WordPress today was 99.99 whatever % secure, the reality is that it's such a huge target that if you invest the effort, even if it's considerable effort as an attacker, the rewards are extremely good because you now have access to 25% of websites on the internet. You can do whatever you want to do. At the same time, with it being WordPress, there are plugins that you can use to help protect the website. And we'll go over those just for a minute. Ninja Firewall, Simple Security Firewall. There are others. Those were kind of the big ones that came up. I'm not a big WordPress fan because of security issues, but the reality is a lot of companies run it. If you're in a case where you've got a company that's running a WordPress site, my recommendation, keep your e-commerce site, e-commerce server separate from whatever server is running your WordPress site so that there's some separation there. And your e-commerce site isn't now subject to the WordPress vulnerabilities as well. So, rolling your own security solution here. The reason why you would do this, as opposed to adopting something off the shelf, is that something off the shelf isn't built specifically for your application. Generally, whatever provider provides you the WAF solution has it configured with some default rule set. Being technically minded, you can probably go in and tweak it, with some of your application-specific settings, some of your application-specific considerations. But again, the reality is it wasn't purpose-built for your specific application. Along those lines, if you're building an application like WordPress that is going out to a large group of users where you have no control over what that end infrastructure looks like, you don't know if there's a WAF in place, you don't know if there's a firewall in place. This site may be running on a shared server somewhere, with minimal security. So having a component to your application built into it to help secure that application can be extremely useful in those cases where you can't guarantee anything about the underlying infrastructure that your customers are going to be using. The advantage here is it doesn't have to be complicated. You don't get some of the benefits associated with cloud solution providers, so you're not getting, obviously, things like content distribution capabilities. You're not getting denial of service attack. You're not getting robust denial of service attack capabilities. But it's really easy, okay? And so, include a firewall file here and you're done. Okay, so that's really where we're going to start from. You've got a PHP file you're including in your application. Now, the advantage here is that regardless of what framework you're using, regardless of how complex the application itself is that runs after that firewall code, it doesn't matter. Whatever your firewall code is can deal with everything coming in that your application is seeing. It can intercept it before it ever touches the framework the application, whatever code it is that you're trying to protect. So what I want to do here is kind of go through some of the things you consider or would consider in building your web application firewall. And if any of you here are PHP developers and you're looking for some example code to work from, feel free to contact me either after this presentation. We can exchange contact information, or online at some point down the road. And I'd be happy to share some code with you. But again, I just want to present a general framework that you would use in securing your own application. So one of those considerations is IP-based geolocation. And the idea of filtering out traffic based on where it's from seems to run counter to the principles of the internet. But the reality for a lot of businesses is that it makes absolutely no sense for someone in China to be visiting their e-commerce site because they don't sell to China. Even if they wanted to sell to China, they simply don't have the relationships necessary to be able to do those transactions, okay? So the reality is that a lot of attacks are coming in from China. If you simply block that traffic originating from that particular country, you've now eliminated, a large portion of potential attacks on your website. Again, kind of runs counter to what the internet was kind of founded on. Russia, North Korea. Some of these countries, even if you wanted to do business and had the capabilities to do business, you couldn't legally do business in these countries, okay? So why open yourself up to that potential source of attacks coming into your website? There's just no need. So, for a lot of companies, if you've got a content website and you're publishing articles, sure, you really have to be accessible everywhere on the internet. If you're doing business, you don't have to be accessible everywhere on the internet. You have to be accessible where your customers are. And the key question here to ask yourself is, by eliminating this particular set of visitors, am I costing my company business, or am I eliminating risk? And if the risk that you're eliminating is greater than any potential business or zero potential business loss, then it makes a lot of sense just to go ahead and filter out that traffic. Maxmine GeoIP API is a really quick, easy way to do this in PHP and lots of programming languages. They have sample code ready to go. It's pretty inexpensive, fairly accurate as well. Although one thing I have noticed, and this is a useful note regardless of kind of what you do, is that now that we've got all our IP version 4 addresses used up, okay, and so things are changing hands now a lot, is I think what we're starting to see is kind of less confidence that some of these new IP addresses that are quickly changing hands between completely different countries, because everyone's so desperate now for a version 4 address, that some of this isn't quite so accurate. And this may affect your decision as things go. It's hard to say at this point. It's still fairly early in seeing how that all plays out. And if you use something like Composer, it's really easy to use GeoIP tracking. All right, Git and Post. They may be file uploads as well to your server, but it's super easy to intercept these before they ever touch your application. Now, if you see calls coming into your application that are obviously structured like a SQL call, and there is zero reason for your application to be seeing that code, why not simply filter it out before your application ever touches it? And that's the general idea here, is that we'll run through all of the things being posted to our application, look for anything potentially malicious, and killing your application is a fairly safe option. The reality is once you've built a robust framework for your web application firewall, is that you might actually take a little bit more aggressive countermeasures here. if you see what's obviously an attack coming into your application, why are you just killing your application? Why not now block that IP address, block that user, maybe even fingerprint the browser that's accessing your web application, so that you really can make sure that that particular user never hits your web application again, okay? And maybe it was a failed attack, but the reality is, if someone's throwing, attacks at your application, it's unlikely to be a potential customer. Another thing that's useful to implement in your application itself are rate limiters. So a human being is not going to be quickly browsing through your website, accessing 10 pages in under a second. That's not a real user. That's either Google, Bing, which are okay. We don't want to block these guys. Probably. I mean, if they're browsing the inside components of your web application, maybe they shouldn't be there. Maybe you do want to block it. But in most cases, when you see something highly unusual, rapid page frequency through your application or through your website, that is probably not a human user. Why are we letting that session continue to go on if we're sending out hundreds of pages, a minute to this particular IP address? So we can filter those. One of the really cool things here that you can do is utilize security services that someone else has already done, someone else has already invested in. So Project Honeypot is one of those, and these are just websites out there on the internet that are there to trap people, to trap potential spammers, to trap potential attackers, to trap any activity on the internet that's generally viewed as malicious or non-productive. Maybe it's not malicious that someone is spamming your website through your contact form, okay? But again, that's also not especially productive. The advantage here with Project Honeypot is that they will classify the types of attacks coming in. Whether it's a spammer attack or whether it's an active attempt to breach an application. They'll classify those access attempts. And so you can leverage all these existing resources that they've provided for you, all this research they've already done for you. And it would be nice, it's a nice gesture as well to communicate back with them when your web application firewall detects some malicious activity from a particular IP address. You can send that right back to them and contribute to their project as well. One of the things that's really useful here is, unless you're monitoring these attacks on your application, unless you're monitoring that traffic, and if you don't have something like Project Honeypot, you don't really know the history of a particular IP address or what company it's associated with. Geo-IP tracking can give you some of that information, but what Project Honeypot will do, actual human beings enter comments about particular IP addresses. So do you want Getty Images to be browsing your website to look for potential IP conflicts? Probably not. Now, you may feel like you're doing absolutely nothing to violate any copyright laws, that every image you have on your website is legitimately licensed. But if you haven't been hit with a cease and desist, and it's not cease and desist, it's Getty Images legal company asking for a ransom, essentially, why subject your website unnecessarily to that particular possibility? Even if every image on your website is licensed, is a company browsing your website looking for unlicensed images someone that's useful to have on your website? Is that a desirable user on your website? Probably not. And if you read more about Getty Images, you'll find out that they are sending letters in a lot of cases, in some cases, to companies that have perfectly legitimately licensed images, Get Images is actually the one using the unlicensed image. But again, they probably have a larger legal department than you do. We can also check user agents coming into our website. So wget is not one of the most malicious browser signatures that's going to hit your website, but it's an example of a common one you'll see. It's obviously not a human being, okay? And unless your application is an API, where you might expect something like this to be touching it, probably there are common browser signatures that you don't want on your website, on your network, using your application. So we can filter those out as well. One of the things that you really have to be careful of as you pursue this and as you get excited and see all these attacks coming in and say, wow, I had no idea. I mean, really, you'll be shocked at the amount of attacks coming in to your website. And initially, these are not targeted. A lot of times what you'll see is just generic attacks, not targeted to you at all. But sometimes hackers will find something that's interesting and will then take it as a challenge to come in and actually breach your website. So the advantage here is that you can see these attacks as they happen. You can see the attacks as they happen for the day. You can start to see patterns, actually. And what might have looked like a perfectly innocent user to your website, you see over time that they're doing things that just look unusual, okay? And the advantage here is that because it's tied into your application, because there's that tight linkage, is that you can easily identify these users. You can see where they're moving through your application. And we'll talk about here in a second how you can actually see what they're looking at as well. But the thing to be careful about here is Google, because Google does trigger a lot of these filters that you'll want to implement for malicious users. Rate limiting filters, Google's probably going to stampede right over that. Google will also access your website using non-standard browser signatures. They'll access your website from lots of different locations. And Google does that to make sure that, for example, you're not sending out different content to different users based on where they're located and trying to trick Google in the process. So you've really got to be careful here that you're not blacklisting Google, because obviously that has a business impact or could have a business impact for you. So we can log user sessions. We can track users by cookies, by IPs. We can record the places they visited on their website. And if you see something suspicious, the advantage here is because you've got a history of this particular user, because you have a way of uniquely identifying that session, you can essentially go back in time and say, okay, this was obviously not a user that I want on my website. The intentions, I don't know what the intentions are, whether it's to hack the application, but obviously it's not an intended purpose for my website. Users banned, users blocked, okay? And what might happen is that this user might have been through your website on 10 different occasions, finally submitted a contact form, and it turns out they're a spammer. Project Honeypot didn't pick it up. It wasn't obvious based on their browsing sessions. But now that you've seen that contact form submission, I don't want this user on my website. And you can go back and block that user. The other important thing here is that as these attacks become more and more sophisticated, historically it might have taken the course of several weeks for someone to breach your application. Today, it can happen in a few hours if it's not an especially secure application. But even over the course of a few days, if you have an extremely secure infrastructure, an extremely secure application, the pace at which some of these attackers can adapt and adjust and change their whole attack on your application now has moved to the point where it's teams and they can do it quickly. They can adapt within days. So you want a way, unless you have a dedicated team that's able to really monitor your application throughout the day, you want a way to help automate some of this. so that when there's a potential attack, even if it's an attack that you haven't seen before, to be able to block that attack. And so detecting patterns and implementing automatic banning of users based on suspicious behavior is something that you can start to do here as well. One of the really neat things that you can do with PHP, I assume you can do this with other languages as well, fairly simply. So PHP has output buffers that you can intercept. And you can actually use this to see what your user is seeing. So when you're looking through traditional web analytics, you can see the address of what pages people visited as they visited your website, as they went through your web application, and you can make some inferences about what that particular experience looked like, what that user was seeing. But the reality is you don't know for sure. And when a particular user is having some problem, you don't really know what that problem was. You can ask the customer, you can ask the user. The reality is most people are not technical, and you're lucky if you get something more specific than I clicked the button and it broke. Sometimes the user will tell you the page that they were on, maybe they'll tell you the button they clicked, but it's very rare that you get the technical information you're looking for. And if you're running an e-commerce website, maybe that only impacts 1% of your users. But that might equate to thousands of dollars of business a day, a week, a month. It equals real business, but because it's such a small percentage of your users, the reality is that it's hard for you to reproduce in-house. It may be impossible for you to reproduce in-house. And because your customers aren't technically oriented, it might take months to track down what that particular issue is affecting 1% of your users. If you're intercepting the output buffers as that session goes on between your server and the user, you can actually see the specific code, the specific HTML that's sent to that particular browser. So to give you a real example of how this is useful, is one of the applications we were monitoring. We couldn't explain why on Macintoshes users were never completing the checkout process. Okay? Everything looked like it was working perfectly fine, but when we went in and looked at the session for that particular user, we knew, number one, that it was Mac, and specifically that it was Safari. And when we actually sat down on Macintosh and went through that session that user had gone through, Apple had done away with their scroll bars on the side. Unless you moved your mouse over to the side, you never saw the scroll bar. And so those Mac users were never seeing the checkout button because it was right below the fold, and there was no obvious indicator that they should scroll down. Okay? And so this is something that when you are capturing those sessions, everything that's being sent over to that user, you can see, number one, you can see when that user is having problems and how to address the problem without the user having to give you any specifics. Basically, you identify that user, and you can go back and look at their particular browsing session and find out exactly what they were doing, exactly what they clicked on, exactly their form submissions if you're capturing get and post calls. So you know exactly what was going on. The other advantage is that if you've got a malicious user, if you're running an e-commerce website, for example, you may see, hey, I just had a purchase come through my website, everything looked good. And that's what you see from the payment gateway perspective. That's what you see in your administrative area. The customer successfully completed the order, everything checks out, but because you're capturing the output to this particular user, if you've got any suspicion about that browsing session, and you go in and look, you may see that user, before they successfully completed that checkout process, they just entered 4 completely different addresses at various locations throughout the United States. And that allows you to pinpoint and identify, hey, this user probably isn't legitimate. So if for no other reason than it being fun, it's useful implementing this because it really is eye-opening. It's eye-opening, number one, because if you're using Google Analytics does not report to you, the number of potential attacks on your application. It's completely transparent. You never see that, okay? If you're doing like online advertising, Google AdWords, for example, that traffic being sent to your website might look legitimate, but do you want to be paying for traffic to your website that's turning around and attacking or hacking your website? Probably not. And so the advantage here when you implement this is you can block out, you can eliminate that percentage of traffic that is never going to buy from you, that only represents a liability to your company, to your website, to your business. And again, don't block Google. And if you do block Google, I mean, you really, especially when you first implement this, really pay close attention to what's going on with your application. If you catch it early enough, you're going to minimize the damage. If this goes on for months before you realize, hey, Google can no longer access my website, the damage has been done. So just be careful of that. So if they're changing numerical parameters in the URL itself, I mean, generally that's a GET call. Okay? So you can certainly implement the ability to track over time how those values change. So you could be tracking a particular variable used passing the URL, and just make sure that that number is staying consistent across the session. Right, and so if you're running a generic web application firewall, you can't deal with that particular issue. If you know for your application, you're never going to see a number between, a number less than, 1,000 or a number greater than, 1 million, you can certainly filter on that range. And if you see something come outside that range, you can block that user. If you see that, hey, that user just tried entering a letter, entering some non-numeric character. Maybe they didn't succeed in breaching the application, but they shouldn't have been doing that. They're blocked, okay? And you can actually track that, log what happened, and if the user contacts you and say, I'm blocked from your application, get the user's IP address, you see exactly why the user was blocked, and hey, maybe you realize this is a good customer, they had a security team who is testing the application for them, let's go ahead and unblock them. They were not, they're not a real threat to our business. Any other questions? All right, thank you for your attention.